Okay, so we're going to go over each one of the sample questions on the ACCUPLACER arithmetic exam. And so I've decided that I'm going to take my time and explain each problem thoroughly so that you can answer the question that we have on the practice exam, but also so that you'll be able to answer questions that are similar to this on your test. I know a lot of you haven't been in school for a while, so if you have a notebook, that's going to be very helpful. So let's start with question number 1. It says, which of the following fractions is equivalent to 0.06? So we are trying to change a decimal into a fraction. The best way to do this is if you can read this decimal properly, then you're able to put it into a fraction very easily. So 0.06, the way you would read this would be 6 hundredths. That's how you would read this decimal. So now that you can read it, you could put in a decimal very easily. The number word, 6, is going to be the numerator, and the hundredths is going to be the denominator, or 100. So 0.06 written as a fraction will be 6 over 100. So I'm going to show you this again. So what if we had 0.15? So again, if you can read that decimal, then you can easily place it into a fraction. So when you read this decimal, you would say 15 hundredths. Okay, so 15 is going to be the numerator, 15, and then hundredths is going to be the denominator. So 15 over 100 would be this decimal as a fraction. So if you're looking at these and saying, okay, it's easy when you know how to read a decimal, but what if I don't know how to read a decimal? Well, that's when we're going to need some practice. So we're going to practice how to read a decimal. If you know how to read a decimal, then go ahead and go to question number 2. You could just fast forward a few seconds. But for those of you who have a little bit of trouble reading a decimal, let's practice that. Okay, so I'm going to write this decimal 0.135. So we're going to just talk about place values when we're talking about decimals, and then we're going to learn how we can read this. So the number 1 is in the tenths place. The 3 is in the hundredths place. And the 5 is in the thousandths place. So when you're reading a decimal, you read the entire number behind the decimal. So this case, I would say 135. So that's the first part. You read the entire number, and then you look at the last digit, which is the 5, and whatever place value the last digit is in this case it's thousandths, that will be the word that you put on the end of your decimal. So 135 thousandths. That's how we would write this decimal that's how we would write that decimal out, or that's how we would read it. So now that we've written it out or said it out loud, we could put it into a fraction. So remember, the number word is the numerator, so 135. And then the place value word is the denominator, so thousandths. So 135 over 1,000. I've made a workbook specifically for this so that you can practice different problems placing decimals into fractions. And I've also practiced how you can read decimals and all the skills you need in order to answer this problem. So if you're like Miss Amber, I still need extra help, go ahead and ask me how you can get the link to my ACCUPLACER workbook. So let's go ahead and go to question number 2. It says, a club has 36 members. If each member donates 12 items for an auction, how many items will there be in the auction? Okay, so anytime we're reading word problems, we need to be able to look at the word problem and identify what the words mean in relation to math. So an indicator word is the word each. Anytime you see the word each, you know that you're multiplying. So what 2 numbers could we possibly be multiplying? Well, there's 36 members and there's 12 items. So we're doing 36 times 12. So now that we know how to do 36, that we're doing 36 times 12, Most people know how to multiply 2-digit numbers. If you're able to do that, then you can go ahead and skip to question number 3. But if you haven't been in school in a while, and I know a lot of you may have been in school many years ago, let's just practice this problem together. It doesn't hurt to go ahead and practice. So we're going to line everything up, 36 times 12. We're going to do 6 times 2, which is 12, carry the 1. 3 times 2 is 6. 6 plus 1 is 7. Then we're done with the 2, so we cross it off and make a 0. 6 times 1 is 6. 3 times 1 is 3. We go ahead and add those two rows together. 2 plus 0 is 2. 7 plus 6 is 13. 3 plus 1 is 4. And so our answer is 432. Excellent work. A lot of people, when they do these types of problems, if they get the answer wrong, then they probably did not cross off the number they used already and remember to put the 0 in the second row before multiplying out. So if you do these types of problems on your own and you get the answer wrong, did you cross off the number that we multiplied by already, and did you remember to put the 0? That's probably what you've done wrong. If you need extra practice with this, please let me know, because I've also made a workbook where you can do extra problems just practicing this. So let's go ahead and go to question number 3. So what is the value of 4/10 plus 3 over 100? So the rule when adding fractions is that the denominators, they have to be the same. The denominators are the bottom numbers. So in these two fractions, are the bottom numbers, the denominators, the same? You're quickly going to say, no, one is a 10 and one is 100. So what we need to do is we need to make sure that before we can add these two fractions, that they have the same denominator. So we have 4/10 plus 3 over 100. So I'm just going to let you know, anytime you have one denominator that's 10 and another denominator that is 100, just make both fractions with the denominator of 100. So this already has a denominator of 100, so we're going to keep it the same. But 4 over 10 does not have a denominator of 100. So how do we make 4 over 10 have a denominator of 100? Well, ask yourself, how did we go from 10 to 100? So 10 times what number equals 100? 10 times 10 equals 100. So if I multiply the bottom number by 10, I have to also multiply the top number by 10. So 4 times 10 would be 40. So 4 over 10 would now be equal to 40 over 100. So now we have two fractions that have the same denominator, so we can go ahead and add those two together. So 40 over 100 plus 3 over 100. Because the denominators are the same, the answer is also going to have the same denominator of 100, and then you can go ahead and add the top numbers. 40 plus 3 is 43. So our answer would be A, 43 over 100. Let's go ahead and go to question number 4. It says, a conference planner has put together 280 binders for attendees and another 31 binders for presenters. How many total binders did the planner put together for attendees and presenters? Okay, so again, we're looking for those indicator words in this word problem. So we don't see the word each, so we're not multiplying in this case, but we see the word and. So if I told you you ate apples and oranges, you would add those two numbers together. So because they put together binders for 280 binders and 31 binders, you must be adding those two numbers. So very simple, 280 plus 31. We're going to practice adding that very quickly. 0 plus 1 is 1. 8 plus 3 is 11. Carry the 1. 311. The answer will be C. So just practice your addition, practice subtracting, and just make sure everything is all lined up when you're practicing this. Okay, number 5. A store stocked 150 cans of popcorn for a weekend sale. That weekend, 72 of the cans sold. What percent of the cans of popcorn stocked were sold that weekend? So now we are looking for percentage. That is the indicator word in this word problem. We're trying to find percentage. So when we're looking for percentage, we usually have an amount out of a total. So we have 72 is the amount, and the total is 150. So we're trying to see how we can change this fraction into a percentage. So if you understand fractions, you'll be able to understand how we can turn it into a percentage. A fraction, 72 over 150, is the same as saying 72 divided by 150. When you divide 72 divided by 150, it will become a decimal point, and that decimal point can be changed into a percentage. So let's go ahead and add a page to this, and let's do 72 divided by 150. So I'm going to go ahead and write 72 over 150. It is now a long division problem. So we're going to look at this and we're going to say, okay, 150 cannot go into 72 as it is. So that must mean we need to add a 0 to 720, and that's very easily added. We can just add the 0. But when you add a 0, you have to add a decimal place right above the place where you've added a 0. So now we have a decimal in our answer. So now we can go ahead and try to calculate how many times would 150 go into 720. Well, 150 plus 150 is 300, plus 150, that's 450, plus 150, that's 600. So I would say it goes 1, 2, 3, 4 times. So 150 can go into 720 4 times, and that would equal 150 times 4, which is 600. Then you go ahead and subtract. 0 minus 0 is 0, 2 minus 0 is 2, 7 minus 6 is 1. And then we go ahead, we can bring up another 0 because 150 does not go into 120. So now we're going to say, okay, how many times can 150 go into 1200? Well, if it can go into 600 4 times, 1200 is just 2 times that amount. So 4 times 2 would be 8. So 150 would be able to go into 1200 8 times. So 1200, subtract, and remaining 0. So now we have that 72 divided by 150 is equal to 0.48. So we're going to go back up here. Remember, if we can turn this fraction into a decimal, which we just did, 0.48, then we can now turn this decimal into a percentage. How do we change that decimal into percentage? Well, 0.48, to change a decimal into percentage, you just move the decimal place over twice. 1, 2, and then place the decimal sign there. So 0.48 would be 48%. So our answer would be 48%. This problem requires many skills. We had to know that a fraction can also be divided and made into a decimal, and that decimal can be made into a percentage. So if you need help practicing, okay, how do I change a fraction to a decimal? And you were like, okay, Miss Amber, when you did long division here, what were the steps? It was divide, multiply, subtract, bring down. But we need to practice that. My workbook, it gives you practice of long division. But also you're going to be like, but I also need to practice changing decimals into percentages. Well, I've also included some problems in my workbook that will allow you to practice simply changing decimals into percentages. That way, when it's time to put the whole problem together, you're familiar with each individual skill that's going to be put together in order to get the problem correct. Please don't give up. I know these problems can seem a little bit intimidating, but after some practice, they're going to come and you're going to be able to do well with it. Okay, so question number 6 is a big one. And I'm so glad that you guys were patient enough to make it to question number 6, because a lot of people have trouble with these types of problems. And the reason is there are fractions in there. And I'm going to be honest, I'm not the hugest fan of fractions either. I see fractions and I'm like, oh man, this is intended just to be more difficult. But we're not going to get intimidated when we see fractions, because as in our last problem, we understand fractions now. Fractions, 8 over 5 just means 8 divided by 5. So now that we understand fractions, we can work with them a little bit easier than before when we didn't really understand fractions. So let's go ahead and answer this question together. It says, what number in the list above has the greatest value? So here we're comparing fractions and we're comparing decimals. So I'm going to go ahead and rewrite that list. 8 over 3. Oop, that 3 looks weird, so I'm going to erase it. 8 over 3, 2.28, 10 over 12, and 0.199. So when you're solving these types of problems, what I would recommend you doing is try to figure out of these 4 numbers, which numbers are greater than 1. Because if you can find the numbers that are greater than 1, then you can eliminate the other ones and you know that they're less than. Our goal is to try to find the greatest number. So let's try to figure out, okay, which one of these fractions and decimals are greater than 1, and then we can compare what's left. So the trick when we're looking at fractions is that if the numerator, the top number, is larger than the bottom number, then that is automatically greater than 1. I'll say that one more time. If you have a fraction, so say the fraction is 10 over 5. When the numerator, the top number, is greater than the bottom number, then this fraction is greater than 1. So we saw 8, the first fraction is 8 over 3. So that fraction is greater than 1. So we already have one value in this list that is greater than 1. Okay, now let's look at this decimal. So this decimal, 2.28. Because this first digit is greater than 1, this decimal is also greater than 1. Okay, now let's look at this fraction 10 over 12. Is 10 over 12 greater than 1? Well, the rule is if the numerator is larger than the denominator, then the fraction is greater than 1. The numerator in this case is 10 and the denominator is 12. So is this numerator greater than the denominator? No, it's not. So this fraction is less than 1. So we know that this fraction is not going to be larger than the other fraction and the other decimal that is greater than 1. Okay, now let's look at this last decimal. If this first digit that's beyond the decimal point to the left side, if this first digit is greater than 1, then it's greater than 1. But this is a 0. So this decimal is not greater than 1. So that is not going to be considered out of these 4 values as to which one is the greatest. So now we're left with 8 over 3 and 2.28. And we have to decide out of these 2 values that are greater than 1, which value is more. So we can't compare a fraction to a decimal without them both being either both fractions or both decimals. Well, we just learned in the last problem how we can change a fraction to a decimal. So let's go ahead and try to apply that again. Let's try to change 8 over 3 to decimal. So remember, the rule with fractions is that if you want to change it into a decimal, you divide the numerator divided by the denominator. So we're going to do 8 divided by 3 to see what decimal 8 over 3 represents. So we're going to go ahead and do the long division. So 3 goes into 8 2 times. And then 3 times 2 is 6. Subtract, bring down the 2. We still need to figure out what comes after because it starts the same as this other decimal, but we have to figure out what comes after. So we're going to bring a 0. But remember, when we bring a 0, we have to add a decimal to our answer. And so now we can go 3, bring down the 0. So now we can go 3 into 20. And how many times does 3 go into 20? 3, 6, 9, 12, 15, 18. So it goes in 6 times. 18, subtract, and you get 2. Bring down a 0, and it keeps repeating. So we have 2.66666. It's just going to keep repeating. So now we have... Ooh, what happened? Sorry, guys. Don't know what happened there, but I apologize. So now we have 2.666 and 2.28 to compare. Which one is larger? Okay, well, the 2 begins the same. So then let's compare the second number, 6 to 2. So which is larger, the 2 or the 6? The 6. So this must be the larger value. So 2.66 was representing the 8 over 3. So 8 over 3 was the largest value. Okay, so we're going to pause the video here. If you have any questions, please let me know. I know I made a few references to my workbook. If you are interested in purchasing the workbook, the link is going to be in the description box. But if you also have any questions regarding the problems that I went over, you can always just comment below, and please let me know what you're working on, where you're getting confused, so that we can practice some more together. Just stay tuned for our next video so that we can go through the next set of problems. Thanks, guys.